Non-rigid parts. A non-rigid part refers to a component that can show different dimensions when it is constrained within an assembly compared to when it is in its relaxed or free state. Materials such as rubber, plastic, or thin-walled parts are examples of non-rigid components that may display this behavior. However, other parts may only reveal their non-rigid nature once they are assembled or subjected to operational forces. In such cases, the dimensions of the part may change due to the flexibility or deformability of the material. When dealing with a suspected non-rigid part, a designer must ensure that the dimensions of the part remain appropriate when it is assembled and functioning. To achieve this, extra precautions must be taken. One approach is to designate one or more tolerances that are applicable when the part is constrained in a manner that closely simulates the restraining forces exerted during assembly or operation. By applying these specific tolerances, the designer aims to account for any dimensional variations that may arise due to the non-rigid nature of the part. This helps to ensure that the part will fit and function properly within the intended system or assembly. Where there is a risk that restraint could introduce unacceptable distortion, the designer should specify mandatory restraint instead. Restraint may be specified by a note such as, unless otherwise specified, all dimensions and tolerances may or shall apply in a restrained condition. Even if restraint is specified for a part throughout the drawing, it is possible to specify a geometric tolerance that applies only to the part in its free state. This can be indicated by using the free state symbol following the tolerance and its modifiers. When the free state symbol is used, the specified tolerance should be verified without any external restraining forces applied to the part. This ensures that the dimensional requirements are met when the part is unconstrained and in its natural or relaxed state.